Alright, so 7.4, we're not going to cover anything new in 7.4. 7.4 is just going to be a video compilation of a bunch of different types of basic probability questions in counting. So it's sort of putting together what we've learned in Chapter 7 with what we need to use from Chapter 6 in counting. And it's sort of a review, alright? So it's just going to be like a review of putting it all together. And the reason why they sort of stop and do this in 7.4 is because the last two sections in Chapter 7 are very difficult, alright? So they want to make sure, we want to make sure, that you have the basics of probability down so that we get into the more challenging stuff, which is in 7.5 and 7.6, which are conditional probabilities, independent events, and Bayes' theorem. You've got the basics down, alright? And once you've got the basics down, it'll make the more complicated stuff a little easier for you. Alright, so again, nothing new. This is just a bunch of videos where we'll be practicing the different types of questions that you will see from the basic probability and counting stuff in Chapter 7. Alright, so remember, basic probability is fairly straightforward. It's the probability of an event is the number in the event, which could be found using a counting technique or a frequency table, divided by the total. And so this is what the basic probabilities are. It's always divided by the total, the universal set. What's going to change in the next sections is that's what's going to change. We aren't necessarily going to always divide by the universal set. All right, again, that's what we're going to be doing in the next few chapters. Right now, though, the basic probabilities are always number in my event divided by number in my total sample space. How many elements are there in my subset out of my total number of elements, right? And so it's a simple formula, but again, we're going to be practicing finding the number of using our counting techniques with our Chapter 7 rules. All right, finding the number in my events, number in my universal set. All right, so the first couple examples are going to be combination types, this video. So again, I'm going to sort of take it a little videos at a time in case you want to go back and watch these. So basically this is going to be, each page is going to be its own video, and it's again just a compilation of different types of problem sets. So this one's particularly looking at combinations, right? So we've got our bag, and again, I'm sure you're probably sick of bag of marbles, bag of candy, but you need to know how to do these. You will see bag of marbles, bag of candy in Chapter 7, you'll see it in Chapter 8, we saw it in Chapter 6, there'll be a handful of them on the final exam. Alright, so we've got our bag of candy here. We're going to reach in and grab 4 marbles at random, and so it doesn't spell out handful as a word, but that's what that's implying. I'm reaching in and I'm grabbing 4 marbles at the same time, which implies handful. Alright, so it is a combinations. Alright, we're going to pick 4 in our combinations. We want to find the probability that all marbles selected are green. So we want a probability that we pick 4 green. Well, it's the number of ways to get 4 green over the number in our universal. And the universal means I can pick any 4. That's what the universal means. Right, and so it's a combination type, right? Combination, the universal set would be I pick combination, choose 4 out of any of the marbles. So how many marbles do I have? I've got 5, 10, 14. So I can pick any of the 14 marbles. That's the universal. The event is that I pick 4 of the green marbles only. So it's combination. I'm only selecting 4 of the 5 green marbles. And again, none of that's new. All right, this is, again, you should have... The idea behind these notes is that you're kind of watching along and you're sort of doing it on your own first. So you're kind of chucking your answer as I go through it. I knew how to do that kind of thing. It should be. These should be pretty straightforward at this point. And then you plug those in the calculator. 5 choose 4 is 5. 14 choose 4 is 1001. And then find the decimal approximation. And again, make sure you're careful. Round to, if it's on test or quiz, it should always tell you what you're supposed to round to. This one would probably tell you to round to 3 decimal places because it comes out 0.04995, and so I'm going to round 3 decimal places. 0.005. So a very slim possibility, very low chance of it happening. Alright, the next one, find the probability. So there's that at least statement again. Again, we've done a bunch of these now, so hopefully these are second nature to you. At least one blue, which I'm going to use my complement for. Remember, the complement rule for probabilities, though, is 1 minus... Right, 1 represents all probabilities. the probability of the event I don't want. Well, the opposite of getting at least one blue, right? One blue would be one blue, two blues, three blues, or all four blues, would be a handful with no blues. Alright, so I want to get rid of the probability where we have no blues. All four are not blue. Alright, so it's 1 minus that probability. So the universal set's the same, and I'm going to write it as, its combinations, just in case, again, we didn't see that. We do know that's going to come out of 1001. Up top would be the no blue case, right? No blue, right? This is the number of ways to get no blue over the number in my universal. Alright, there's my universal. And so up top, I want 4 that are not blue. Well, how many marbles are not blue? Well, I throw away those 4, which leaves me with 10 marbles possible that are not blue. So 10, choose 4. Alright, so it's up to you. You could plug this all in the calculator at once if you wanted to. If you wanted to type in 1 minus, again, I would put parentheses around combination 10, choose 4, divided by combination 14, choose 4. And you could just plug it in all in one shot. Biggest thing is that, put parentheses around this fraction. Or you could find those numbers and then do the division and the subtraction. Alright, so combination 10, choose 4 would be 210. Combination 14, choose 4, 1001. And then again, always a good rule of thumb whenever you're adding and subtracting fractions to put parentheses around it. The decimal approximation to that is 0.7902 if I round 4 decimal places. Alright, so make sure you're careful. This one is, make sure you're careful plugging it into the calculator. Again, don't round until the end of the problem, so don't round this fraction. Type this all in exactly. You don't want to round until the very end, because then you could be significantly off, and you don't want to be significantly off because that could cause you to type in the wrong answer on the quiz, right? The quiz needs to be as close to exact as you can get, alright? So no rounding until the very end of the problem. So that means type it in exactly. Either type it in as the formula up here in your calculator or type it in here. Again, my rule of thumb is always put parentheses around the fraction. So 1 minus the fraction 210 over 1001. Alright, the second example. Alright, suppose the lottery requires you to select 6 numbers between 1 and 54. Order is not important. Alright, so that means combinations, right? At this point, you should be automatic. That means combinations. Drawing at the end of the week will determine 6 winning numbers. Find the probability of correctly matching. Again, we'll do those in a second. Now, this problem was actually asked, I believe it was part 6 or part C that was asked on the final exam. On an old final exam, and students had trouble with it. They had trouble setting it up. And so there's a few things. Again, first of all, order is not important, so that should be automatic. I know it's combinations. Secondly, we're going to pick 6 numbers, and we have 54 to choose from. Right? Because 1 to 50, right? There's no 0, so it's just 54. 1 to 54, there are 54 numbers we could select, and we're going to pick 6, and at the end there'll be 6 winners. So 6 of those 54 now, and that's sort of what we want to break it down to. There's 6 of the 54 winners. Alright, winning numbers. 6 winners. So I'll write it out. 6 winning numbers. Which is what you want, but that means if 6 of these numbers are winners, that means there's a chance of getting 48, right? If you take 54 minus 6, there's 48 losing numbers, alright? 48 numbers that were not selected as the winning numbers. And so that's sort of what you gotta kind of think about in this problem. Alright, so the first question, what's the probability of picking basically winning? What's the probability of winning? Alright, so probability that you pick the 6 winners. Well, it's the number of ways to get the 6 winners over the number in my universal. Remember, the universal is I can pick any 6. They can be any of the 50 more. They might be winners, they might be losers, right? So any of the 54. So up top is combinations. I'm picking 6 of the 6 winners. I'm getting all the winning numbers. In the bottom, I'm going to pick 6, and they can be any of my numbers, right? That's what I go. I go and select, and so there were 54 choices when I went to select my numbers. All right, and this is going to be a really big set. Right, up top, it should make sense that if I pick 6 out of 6, and if you plug it in the calculator, it will come out 1. There's only one right way, right? There's only one set of 6 winners, all right? So you can only get it one way. In the bottom, however, is a really big number, and make sure you're very careful when typing in this out. It's 20, 3, 5, 8, 5, 2, 0. And this particular type of problem, if it did show up on a final or a quiz, it would probably show up as a multiple choice because we wouldn't want you to mistakenly type this in. It would be really easy to do. And we would leave it as the fraction because the decimal, if you type it out, gives you scientific notation. And it's to the negative 8, so there's 7 zeros. 7, and then round 4, 9. Right? Which that's really, again, it's a really small odds of you winning. This is how we'd probably leave it as the answer choices that you'd have to select from. Alright, so that's the probability of winning, getting all 6 numbers right. What's the probability they get 5 out of the 6 numbers, right? Exactly 5 winning. This one's tough because there's a hidden and statement. Alright, so probability that you pick 5 winners. Well, it's the number of ways to get 5 winning numbers. But there's a hidden and statement. I always have to pick 6, right? I have to pick 6. I have to complete my handful. Well, if I picked 5 of the 6, so I picked 5 of these, I still have to complete my handful of 6, or my choice of 6, not handful in this case, but my choice of 6 numbers. And that means I selected one of the 48 losing numbers, and so I need one of the losers. Still over the universal set, and that doesn't change. And so up top, it's going to be combination. I'm going to pick 5 of the 6 winners and 1 of the 48 losers over my universal set. All right, which is the same as before. 54 choose 6. All right, so up top, combination 6 choose 5 is 6. Combination 48 choose 1 is 48 over my universal set. And I'll write it out in a second. 6 times 48 is 288 over that same number up here. 2, 0, 3, 5, 8, 5, 2, 0. Which again, if this were a question asked, this would be one of the multiple choices. We write this as multiple choice, and you have to be careful to select that multiple choice. Right, and there's the odds. And again, it's also very small. It's slightly better than the one before, but not much. All right, the last one, which is actually the question that was asked on the final exam. What's the probability of getting at least one of the winners? So I picked 1 out of the 6, or 2 out of the 6, or 3 out of the 6, or 4 out of the 6, or all 6 out of the 6. Well, again, the complement's the better way to go with this. All right, probability I get at least one winner is 1 minus the probability I don't get any winners. There are no winners. Alright, they're all 6 are the losing numbers. Right, so 1 minus the number of ways to get 6 losing numbers over the number in my universal. And so it's 1 minus, well, combination up top, I'm going to pick 6 of the 48 that are non-winners, losing numbers. This is still my universal set, 54, choose 6. And so there's a couple ways you can do this. So this is where, again, be careful on the calculator. This one, actually, I am going to find the decimal approximation because it's actually kind of a nice decimal. You can either type it in 1 minus, if you want to, this formula. 48 combination choose 6 divided by 54 combination choose 6. Just make sure you put parentheses around the combination so it follows the order of operations correctly. And you can type it in exactly like that. So on the calculator, it's 1 minus parentheses 48 combination choose 6 divided by 54 combination choose 6. Or you could find those numbers, which they are fairly large, and I'll write them out here, and then do the subtraction and division. Alright, so that's the same number we had before in the denominator. This is the universal set. 2, 0, 2, 5, 8, 5, 2, 0. Up top was 1, 2, 2, 7, 1, 5, 1, 2. And you could subtract that way. You could take 1 minus this fraction. Alright, so either way is fine. This is probably, I would probably type this into the calculator because I'd be less likely to make an error that way. Both of these numbers are so big, it'd be really easy to mistype something on the calculator. Alright, so I would probably use this technique, but again, you pick your poison. If you do, it should come out to be about 0.5249. So the probability of getting at least one winning number, of you choosing at least one of the 6, which means you could choose 1, 2, 3, 4, or R6, is a little bit better than a 50% chance. You have a 52% chance of doing that. Alright, so we're going to stop there. So like I said, we're going to sort of do 7.4 kind of by pages, since it's really a review. This is just a review of your basic probabilities that you need to make sure you've got down pat. You have them down where you can, as soon as you read the problem, you know how to solve it. You can solve it fairly quickly, all right? Because we're going to get into the harder stuff in the next week, which is 7.5 and 7.6. All right, so we'll stop that there. We'll pick up the 7.4 notes in the next video.